viewers, welcome to the fundamental physics classes by Yashu, myself Yashoda. In the last few videos, we'll try to understand electricity chapter part 1 and 2. In this class, we'll try to understand the Ohm's law. Okay, how this gives a relation between voltage and the current, we're going to understand that. See, you know that first of all, to understand this, conductors and insulators, right? Conductors which allow electric current or electrons to pass through them, they're what we call as a conductor. They'll allow electric current to flow through them. And insulators means they do not allow electric current to flow through them. They are called as a insulators. Does not allow because conductors will have the free electron. They will contain the free electrons so that it will allow current to flow through them. Insulator does not contain, okay, they does not contain any free electrons to flow the charges through them. That is why your free electrons are there, so conductance will allow electrons to flow through them. They're called conductors and this is called insulators. Now, these insulators in conductors also, even though electrons are flowing, but not in the same rate for in all the cases. Okay, we can see like iron will take, okay, and you'll take aluminum or you'll take gold or silver. Okay, based on the different materials, the current and amount of current flowing per unit time, right? The amount of charges flowing per unit time, that is what current. So that is flowing of charge will be opposed by some of the materials. Based on this, iron will oppose more current. Okay, which will opposes the current to flow easily. Aluminum, gold, silver. Here, gold is a good pure conductor, and silver, okay, copper is a little pure conductor, good conductor, like that. So, conductivity of this materials is also in turn depend. So, what factor it will decide, that is based on the resistance. Okay, resistance is a material, or resistance is a property of a material that will just opposes the flow of electrons. Okay, just is opposing, it's a present inherent property of that material. Iron will have some resistance, aluminum have resistance, like that. Based on the resistivity of that material, the alloyants or conductors will allow the current to flow through them. Let us see how they are related. Okay, that is, it was stated by the, okay, this relation, the relation, when you increase the potential, that means when you increase the potential more and more, that time current is coming is also increases. Okay, the relation between how much we increase current, how much the current will come. That means when you increase the voltage, how much current will come. Or when we pass the current with some extent, how much voltage is going to increase. So the relation between the current and the voltage, okay, it is given by the great scientist called okay, Simon Ohm. Okay, this is a Simon Ohm photo, just to observe. He only given the Ohm's law. Okay, this will be valid from since 2 years. It is be valid. Okay, it states that it consists at constant physical conditions like temperature are kept constant, then amount of current flowing through the conductor is directly proportional to potential difference between its ends. Suppose in a circuit, okay, the potential difference between the ends, let us take these two free ends, they are going to connect to the battery or cell. How much potential difference between A and B? Okay, that is, let us take B. That is directly proportional to what, children? It is directly proportional current flowing through the circuit. How much current is flowing, that will be decides how much, what is the potential difference between that. That is, current flowing through that is directly proportional to the potential difference indirectly. Okay, how much current will flow in a conductor? Okay, that will be depending upon potential difference between the two ends. Okay, across its ends. Conductor is directly proportional potential difference between its ends. Suppose let us take one conductor at point A. This potential at this point is VA. Potential at this point is VB. So what is the difference in potential that leads how much current will flow inside? Depends on. Okay, children. So that is given by V is equals to I. V is proportional to I. The proportionality symbol in the physics we just remove and put the constant quantity called R. That is, R is a constant called resistance. See, many times in the MCQs questions they'll ask, I is proportional to V, I is proportional to R, okay, V is proportional to R. In this, among this, which is correct? Okay, V is equals to I by R. Okay, among this, which statement is true, they'll ask. Definitely, this is not true. By saying, you can tell this, by saying this equation 1, let us say, you can tell that. But you can see I and R. Okay, this is also false because it's proportional. V is proportional to R. See here, V is there, this side R is there. So we cannot write this statement, V is proportional to R. We can write I is always proportional to V. Okay, V, potential difference. We cannot write all this because, okay, we cannot write V is equals to, okay, V proportional to I also. We always write only thing that is I proportional to V according to the Ohm's law. That means amount of current flowing, that is V directly proportional to potential difference. So all these other ways of representing is the false ways of representing. If they give MCQs, only this is the correct. Because this is a constant for that material, it does not depend upon how much voltage you increase. Okay, if you increase how much voltage or if you provide how much current also, it does not depending upon current increase or voltage increase, right children? That is why R will be constant for that material. Okay, that is why we cannot write V is proportional to R. Okay, I hope this is clear. R, we cannot write I is proportional to 1 by R. These are the wrong ways. Only we can write I is proportional to V and V is equals to IR. Where R is a resistance called resistance. Okay, resistance. Okay, R is called as constant. It is a constant that is called as a resistance. V is equals to IR. This is statement and write at constant temperature. Okay, basically all physical quantities are constant, like temperature kept constant. Then this is important, amount of current flowing through a conductor, amount of current flowing through a conductor, how much current will flow through a conductor, that is directly proportional to potential difference between its ends. Let us take potential EVA, and here what is the potential difference between the ends? That will be depend how much of current is flowing. Okay, according to Ohm's law, conditions are divided into two. One is ohmic conductors and non-ohmic conductors. Ohmic means which will follow the Ohm's law. That means as an increase in current like this, as if you increase the, suppose the ultra current versus potential, as it increases the current, one potential also increases in the same manner. Again, the current increases, potential also increases. Current increases, potential. That means in how we draw no uniform motion. How in case of uniform, how much distance and time. Okay, we both, sorry, we can write always time here and distance. So time and distance are equally varied, no, in case of uniform graph like that. If that straight line passing through the horizon, it is a uniform motion. In case of kinematics you study like that. In case of here, when the line is parallel, okay, that, sorry, line is passing through the horizon. Okay, if you draw the versus the potential versus current or current versus potential, that time it will obey the Ohm's law. If line is like, if a line is not like this, it is somewhere other like this, curved or curved outward or inward or any other shape, that time we can tell it is a non-ohmic devices. Okay children, what are ohmic devices and non-ohmic devices is clear. We'll see examples also later. Now try to understand this slide. What is Ohm's law? Ohm's law is when at a constant temperatures, all physical quantity like temperature is constant, amount of current flowing through a conductor is directly proportional to potential difference between its ends. Okay, this is what the statement of Ohm's law. We given by formula I is proportional to V or V equals to IR, where R is a constant called as resistance of the material. Okay, we'll see what is that resistance means. Yeah, if you draw the graph, okay, versus current versus potential, okay, current versus voltage, you can draw the graph. For ohmic conductors, it looked like a straight line passing through the RSL. And if for non-ohmic currents, okay, non-ohmic devices, they will not follow the straight line. They'll see when the current increasing, but potential is not increasing up to 2 factor. Okay, like this, it will be graphs look like. Okay, by seeing the graph, you can tell whether the device is ohmic or non-ohmic. Yes. See how to remember this Ohm's law, because base so many problems they ask on this Ohm's law. Just it is a hint, is that Ohm's law triangle. So how to find voltage? Suppose they will give current value like 2 amperes. If they give resistance of the circuit is 1 ohm, that time how you going to calculate the voltage means, see, just write the triangle V. Here V is, like that you write the V at the top. Okay, I and R you write at the down. So here V you want to see how the I and R there, they are parallel. Okay, they are at the side. So multiplication they are. Okay, this symbol indicates multiplication, this indicates division. So just you write I into R side by side. And you want to find the current. Suppose again voltage is 2 volt. Okay, current is resistance is constant. That time how to find current? If the current is there where? Here. identify the current, write I here and see it is divided by. So V by R, you write V by R division. And again you can see here the third condition, you want to find the resistance. The given current and the voltage and given, you need to find the resistance that time. So R is there here. How they are in the division form. So we can write V by R. So just to remember the triangle, okay, just write voltage, current and the resistance. So what you want to find, that you get the encircle and how their multiplication. If there are line indicates division. Okay, this is the indicate division and this indicates multiplication. Like that, you're going to remember this easily to solve the problems. Okay, children. Yeah. See, Ohm's law you can verify by in the laboratory by connecting these other devices are required. First, what you required is a cell. Okay, the cell of 1.5 volts battery is required. This is a source. When you pass this current through what you require a wires, you just pass this through first. See this side, if we let us say this is a positive terminal and this is a negative terminal of the cell. So positive terminal is going to connect with the rheostat to adjust the voltage or nichrome wire. We take a nichrome wire that is nothing but act like a resistor. Okay, resistor to adjust the resistance. And again that end is one end is connected to negative of the voltmeter and the positive of this is connected to this. That means how the circuit move. Just to see children, this is a cell, we going to connected a cell and from the cell we connected resistance. Okay, from the resistance we connected voltmeter in parallelly connected voltmeter. Okay, through this resistance. And here the switch, okay, the switch like a plug key they connected and they connected ammeter here. Okay, ammeter we always connected series and the resistor we are going to connect like this. So when you connect all the terms like this, now you're going to adjust. Okay, when you're going to resistance, you're going to adjust and you're going to see the voltage. Okay, voltage here we're going to note down and current in a milliammeter. In the ammeter we're going to note it down. Okay, like this we're going to note down the current and the voltage by changing the resistance of the wires. So we can going to draw the graph as a given voltage, what is the current, and given current, what is the voltage, like that we're going to note. Okay, let us see the table. This is the arrangement. Okay, just to check the arrangement, how we're going to arrange. Voltmeter, I said already, always we're going to connect with parallel because it have high resistance. And ammeter, we're going to connect series. Okay.